Okay, welcome back. And in this video, I'm going to be starting a new project. And some of you might be wondering why I'm starting a new project when I have several other projects that are not quite done yet. And the answer is simple. It's because I want to. Now, this is actually a tool build. It's going to be a tool project. And it's one of those tools that I don't have a use for yet, but I do have some ideas for projects in the future that might require it. And it's a tool that I've been wanting for several years, and but I just haven't got one yet. And I'll explain why here in a second. But anyways, that tool I'm talking about, some of you may have gathered from my masking tape. I don't know if you can see the white tape on the whiteboard here, but my masking tape layout here is I want to build a pantograph, more specifically a 3D machining pantograph. And you might also be wondering why I want a pantograph if I already have a CNC router. And again, the answer is very simple. So anyways, sometimes you can find a really nice used, obviously, pantograph online. There is one on eBay now for about 500 bucks. And the problem is, well, there's a few problems. One is it's about a 2.5 hour drive away. Now, I've driven further than 2.5 hours before, so that's not a game changer. That's just one issue. It's a 2.5 hour drive away, maybe closer to 3 hours. But also, it's 500 bucks, which is not a ton of money, but it's still 500 bucks. And the third reason is I really don't have room in my shop for that size of a machine. I mean, it's like a big floor standing. I mean, it looks like a little Bridgeport or something. I mean, it's a decent machine. I mean, it's not huge, but compared to my shop, it's a little bigger than I can really find room for. Now, all of those things combined makes it to where I really don't want to go get it. Now, if it was just down the block, I would spend the 500 bucks, go get it, and I would figure out how to make room in the shop. Or if the thing was like being offered for free, then I would go get it. Or if I had a much larger shop, I would go get it. But all of those things are making me lean towards building one myself. So I started laying out the design for it, like about the size that I want. And I have seen some examples online of people building pantographs, and all of the examples I've seen, they were made out of wood, like chunky wood, like 2x4s and stuff like that, with a router mounted into it. And the problem with that is, I mean, that would probably work, but I really want to be able to machine aluminum parts. I want something a little more sturdy and robust than wood. And also, I want to be able to configure it to do a 1:4, 1:3, 1:2 reduction, or incretion. Is that a word? Yeah, you know what I mean. I want to be able to go between like fourth, third, and half changing. And on all of the plans that I found of those wooden ones, they didn't look like you could configure them. It just looked like they were what they were. And I didn't see anything on them explaining if they were a 1:2 or 1:4 or one or whatever it was. I didn't see anything about that. I'm sure there are some online that do explain that, but I don't have patience to search for any more than about 10 minutes. So anyways, I got a few ideas. I looked at some pictures of the actual real machines to get an idea of how they're made. And I just started laying out just a random shape here to give me approximately what I'm looking for. Now, one of the projects that I have in mind that I want to use this for, I want to take a large thing and machine it down into a small thing, about a third the size. And so I made it to where I could fit that large thing over here and still have plenty of room to work around it. And I don't want to go into details of what that project is, just in case I don't actually start it or do it. And in fact, this idea here, this is one of these ideas to where I honestly don't know at this point if I'm actually going to go through and finish it. I would like to, because obviously I would like the machine, but it's just one of those things that, I don't know, in my mind, it seems a little bit out there, maybe. I don't know. I'm just kind of rambling for now. So anyways, I got this basic layout here, and then what I did is I fabricated it a kind of a mock-up in wood. And here is the wood mock-up. And basically, if we take a look at this, I have my main mount pivot that's just bolted into a 1, 2, 3 block, so I can pivot here. So this is the anchor point. And I have the main arm, and the main arm is 24 inches long. I chose, it's between points, between centers here. I chose 24 inches because that makes the math real easy. So if I want to do a 2-to-1 reduction, I would use the hole at the halfway point. So that's at 12 inches. And then a 4-to-1 reduction, cut that in half again. That gives you the 1/4 scale here. And then I put a hole here for 1/3. I also put a hole for 2/3, but I don't think I'm going to use a 2/3. So I kind of just cross that off. So that's the main arm. And then you have another arm just like it. And again, 24 inches long with a halfway point here, 1/3 and 1/4. And then you have these two smaller arms. And from this point, which this will be the spindle end, this is where the cutter will be. This is the 1/4 mark, the 1/3 mark, and the 1/2 mark. And I have another arm over here. It's the same thing, 1/2, 1/3, and 1/4. So from here to here is 12 inches. So, you know, just looking at these dimensions, if you look at the main arm, again, it's 24 inches. And again, it's just simple math. 12 inches, 8 inches, 6 inches at that pivot. So right now I have it set up for a 1/4 scale. So again, 6, 8, and 12. 2/3 is 16, but again, I'm not going to use that. And then with this arm here, again, from where the cutter would be, we have 12 and 16 and 18. And on this arm, we have, again, from the cutter, 12, and then to the third we have 4, and then to the 4th we have 6. And so what happens then is, if you have a stylist at this end right here, and a cutter or a pen here, whatever you do here will be copied over here, but at, in this case, 1/4 the scale. So to change these scales, you know, if I just unscrew it here and then connect that 3 to the 1/3, and then do the same thing here, connecting that 3 to the 1/3, then that'll give me a 1-to-3 reduction. Or if I could take the center point here for 2, put it at 1/2, and then the 2 here for here at 1/2, that'll give me a 2-to-1 reduction. So that's the thought behind it. Now, obviously, this is way too flimsy. This is just mock-up to make sure my dimensions are correct. So if we just kind of demonstrate how this works, I'm going to clamp this end down, and I'll put these where you can see both ends. And I'm just going to tape a piece of paper under each end there. And what I'll do is I'm just going to clamp a pencil, and then I can use a marker in that hole, and let's just draw a shape and see what happens here. So I'm just going to do a square. Close enough to a square. Now keep in mind, when I laid out all of my holes, I just, you know, I held up a tape measure, marked it with a Sharpie, and then drilled it by hand. So they're not going to be exact. You know, that 6 inches is more like 6 1/8. And the 8 inches looks pretty good. The 12 inches looks pretty good. But yeah, all of these holes are going to be very slightly off. So I don't expect this to be exactly 1/4, but it should be pretty close. And you could actually tell it's a little bit skewed. That square is a little bit leaning that way more than this one is. So yeah, my drilled holes aren't quite perfect, so it is skewed a little bit, but it should be close enough. So if we measure that end right there, 2.1 inches, divide that by 4, 0.525, So let's see how long this one is right here. 0.6. I don't know if you can see that. So it should be about there. So it's a little bit long, you know. If we take a look at the length at the top line, that's 2.4. And then that should be 0.6. Well, that should have been easy math. 0.6. So it should be 0.6 right there. And we're looking at actually pretty close. So my left or right is pretty much spot on. My up and down is a little bit off. But again, I did not expect it to be perfect because I didn't really, make my holes exactly perfect. Let's try a circle. Well, the bottom of the screw point there is catching on the table. So it's keeping me from doing a perfect circle there. Let's try a little bit further. Let's try up here. We'll try here. So the circle's an oval. But again, we already knew that because that square was leaning over. So anyways, this is the idea behind a pantograph. And you can get little cheap ones of these made out of plastic just for drawing and sketching, which I had one years ago. I don't know where it went. I think I threw it away because it was pretty much junk. It didn't really work all that well. But something else I want to try and figure out here. When I looked at the wooden pantographs, they actually mounted the router right here on this line. They didn't mount it right at that point here. And I don't know how that affects the math. So I'm going to try that real quick. I'm going to put this right in the middle because that would be easier. If I could mount the spindle in the middle, that might be easier than mounting it at that pivot. So let's just see how that affects the dimensions. Oh yeah, it's definitely, that definitely skews things quite a bit. So yeah, that's the square I drew and that's what it did. So yeah, that's definitely no good. Now I know that could be fixed. If I changed the geometry of this, I'm sure it would work. But I don't know if I'm that smart right now to figure that out. I don't know. So, and that might be why it was a little bit skewed that way, is because I had the pencil not on that center point. I bet if I put the pencil here, it would skew the other way maybe. Let's try that. It didn't really change the circle that much. It does look a little bit smaller. So that does affect it. So I think I need my spindle right at that pivot point here. Like I said, I know it can be done putting it here, but you would have to change the geometry quite a bit. And again, those the plans that I saw for this online, they had it specifically for here. They didn't really, at least the ones I saw, they didn't really explain the geometry that well. If any of you know of one that does show plans with it mounted here and they explain the geometry perfectly, then, send me a link or something. But for now, I'm thinking I really need my spindle, my cutter, to be at that point here. And then we should be good to go. Now, I do want this to be a 3D pantograph, meaning if I lift this end, I want that end to come up as well. And theoretically, since it's going to pivot, it'll pivot at this point right here. If I raise that up, pivoting here, that should be 1/4 the height of that point, no matter where I put it. So that's something else I'm going to have to play around with, but that should work. Looking at photos of the real thing, that looks like how they're set up. Another thing is, I would like to be able to go either way. I would like to have a stylist here and a spindle here for making smaller parts. I would also like to be able to put a stylist here and a spindle here for making larger parts. And to do that, I think I'm actually going to buy 2 spindles. I'll probably use like an ER20. I can get an ER20 collet, if you're not familiar with what that is. This is an ER32. This is what I use in my lathe and the milling machine. And my little desktop CNC router uses an ER11. It's the same thing, only like really small. And so I could get an ER16 or an ER20. I think an ER20 is good to hold up to 13 millimeters, I think. An ER16 will hold up to 10 millimeters. So I'll probably, either one of those will be fine. I don't need a huge cutter on this thing. So, but I'll probably go with an ER20. And I can get an ER20 collet with just a straight shaft. This is an MT3 right here, so it'll fit in my lathe. But I can get one with just a straight bore shaft, about 3 inches, 4 inches long. And then I could just put that in some bearings at the pivot point. And then I could just have another one over here to hold a stylist, and then have a pulley on the top of them and use a belt pulley system to drive whichever spindle I want. And then I could just mount the motor. I could mount the motor here, or I could mount the motor over here somewhere. All of that stuff, I haven't even figured that out yet. I'm right now still in just the very beginning phases of thinking about starting. But obviously, wood is going to be a little too flimsy and flexible for what I want. I need this to be very rigid with very little or no backlash or twist or slop. So let me show you what I plan on using. I plan on using this. This is a large chunk of aluminum, and this measures 3.5 by 1.25, and right now it is 37 inches long. I got this huge chunk just for one project. I got that whole thing. I got this entire bar of aluminum just to make 2 square blocks that I used to press out these wheel halves out of copper. Those wheel halves go together like this. And then once that wheel is done and spoked, looks like that. That's for my 1/8 scale Jaguar build. That is currently on hold until I get my commission build done. And, but yeah, for those of you who are following along on that Jaguar build, I apologize. It's been forever since I've worked on that. But just be patient with me. I will be getting back on it. But I got to get this commission build done first. This one right here, this is, I got some downtime because I'm waiting for paint to arrive, and plus the weather isn't good for painting right now. So I've got some downtime on that commission build, so that's why I'm just taking a sidestep project to work on this for a little bit. But I will be getting back on this at some point, so be patient, bear with me. If you have not seen the build of these wheels or that Jaguar build, check out my channel, my playlist, and see how I did that. But anyways, I bought this entire bar just to make the tools to make those wheel halves. Because if I would have had them cut this down, it would have cost a lot more. This whole thing was only like 45 bucks. And so what I want to do is make the arms out of this. Now, this is way too beefy for what I need. The main arm right here only really needs to be, maybe 2 inches. So what I might do is split this lengthwise. Maybe I'll do like 2 by 1.5, and actually the saw blade, the saw kerf, and milling it flat will take some material. So it'll probably be, you know, a little under 2 inches and a little under 1.5 inches. But that should give me, the thicker one will be for the main arm, and then the other one will be for this arm. And that's still probably way thicker than I need. I actually went online and I found a materials twist calculator, and 1.5 inches by 2 inches, 1.5 inches by 2 inches at 2 feet long. So just imagine this bar right here, 1.5 inches by 2 inches, and it's 2 feet long. If the weight of this over here trying to twist it, if you put a force of 40 foot-pounds, which is just a made-up value, basically, that would be like 10 pounds hanging off of the end of this. That's only going to twist less than 0.2 of a degree. And I really don't think I'm ever going to have 40 foot-pounds of torque on that end of it. So it's going to be way overkill. But keep in mind, I want this to be sturdy enough to actually do some machining. I don't want any vibration or slop or backlash or twisting or flexing or anything. I want it to be so I can do some actual decent machining with it. And plus, this bar has just been kind of kicking around the shop for a while, and I need to do something with it. So this will get cut up to make the arms. Now, these two arms here, they don't need to be as thick. They can be a little bit smaller. I don't know if I have enough to get everything. I might have to buy some more material. But as far as the mount here, that center mount, I went ahead and bought some 1 inch by 10 inch black pipe and a mounting flange. And so the plan is, obviously that screws together. The plan is to bolt this to a steel plate. I have a steel plate that I'll probably use. It's maybe, it's not 1/4 inch. It's thinner than 1/4 inch. It's bigger than 1/8. Maybe it's 3/16, something like that. So I'll probably cut a piece out of that steel plate about the size of my workbench and bolt and weld that to the corner. And then this will be the main anchor point. And I'll cut a chunk of this aluminum that will go around it and clamp to it. And I can, with some bolts, I'll drill a hole, split it, and put some bolts in it. So I can loosen the bolts and slide it up or down that post, kind of like the bed on a drill press, or just like the bed on a drill press. So I can adjust the height, but that piece will then have like a double pivot, because it has to pivot back and forth, obviously, like that does. But to make it a 3D pantograph, it also has to pivot up and down this way. And so that's the plan. This is where I'm at. I don't know exactly when I'll fully get started. I mean, I guess I did get started. I bought some parts for it and made a mock-up. But as far as actually making the parts, like the arms and the swivel and the base and all that, not really sure exactly when I'll do all of that. I have not ordered the spindles yet. I guess I probably should, so I can start working out the the pivots and the bearings and all that. Like I said before, this is one of those projects that at this moment right now, I'm not positive I'm actually going to go through with. It's more of an idea that I'm thinking out loud with. So the reason why I'm doing a video now is kind of twofold. For one, if I'm putting it out there for the public to see, then that will help me go ahead and finish it. And also, just in case any of you have a similar idea of making something like this, maybe it'll give you some ideas. Feel free and copy anything I came up with. Pantographs has been around a lot longer than I have. It's not like I invented this. But if I gave you any ideas for your build, that's great. If you have any suggestions, If any of you know of better plans that show how to put the spindle here, send me a link and I'll check it out. I'm not saying I'll do it that way, but I'll definitely check it out. But any thoughts or comments are welcome. But I think I've rambled on plenty long enough. So I appreciate you guys for hanging out and checking out my next possible future project. And until next time, thanks for watching.